Welcome to the Terrestrial Navigation Tides video. As you can see, we will be working on a U.S. Coast Guard question, so let's get into it. What will be the time after 10 o'clock EST, zone description +5, on the 4th of March 1983, that the height of the tide at City Island, New York will be 2.4 feet? So there's a couple important information to not jot down right here. So our location is City Island, New York, and our time is 10 o'clock, and we are in EST, not DST, and our date is the 4th of March. So now that we have this basic information down, we can go into the Tides book and go to the pages of index. I have already printed out some of these pages for us to use. So let's look through here and look for City Island, New York. So you'll see they're listed in alphabetical by column in the 1983 book. So City Island is right here, and the station number is 1261. So we'll come over here and write the station number 1261. And so now we go over to the station number pages, which are in table 2. So go ahead and flip through your book and try to find that. I have again printed out the page that we will be needing for this. So 1261, you can take your index card and lay it straight across there and then slide it over, and you'll be able to read your information. So with this table, we have our differences. So over here we have our times of high water and times of low water, and over here we have our heights of high water and our heights of low water. These are to make it easy, so you know when high tide is and when low tide is for the stations. So we have City Island, and our corrections for this station is 0003, -0003 for our times, and then for our heights it's +0.1, and there is no change on the low water height. So let's go ahead and write those down. So table 2 information, we have our high water time correction, which was 0003, and our low water correction, which was the same. And then high water height correction was +0.1, and there was no low water correction, so you can just write in zeros for that. So next we'll have to go to our daily predictions. So the daily predictions are done by these right here in bold. So for this particular one, we want Willett's Point, which will be on page 52 in your Tides book. So let's go ahead and flip to page 52, and don't forget to write that down at the top. The point of writing down all of this information at the top is so that when you screw up later on in the problem, because you and I both know that it's going to happen at least once, you don't have to go back all the way to the very beginning when we went back into the table of index to find the station number and then find the page number. So this saves you some time with those steps, especially when you take license, which is timed. So for our daily predictions, on this page. It is March 4th. So you come over here to the March column, and then you're going to come down to the 4th, which is right here. So our time listed was 10 o'clock. So we want times where 10 o'clock is between. So for this problem, 10 o'clock is between 0955 and 1547. So we can go ahead and write those times on our sheet. So 0955 and 1547. So the next thing you'll see over here is that the heights are listed for, that there's 2 heights listed here. So the one on the right is in meters. We do not want that one because the question was asking for our answer in feet. And so you'll have to look at this column. But you need to know which one is high water and which one is low water. You decide that by the feet listed. So the 0955 is negative 0.4, and for 1547 it is 6.5. So 6.5 is greater than negative 0.4, so that's why earlier I went ahead and listed 0955 as low water. So I actually screwed that up, but it doesn't really matter as long as you change your labels. And 1547 is our high water. So 1547 lists 6.5, so 6.5 as high water, and negative 0.4 as low water, like we were shown on the chart earlier. And then from here, you get to do some math. So 0955 minus 3 is 0052, or 952. And then 1547 minus 3 is 1544. Then we just bring these numbers down, so 0.1 plus 6.5, 6.6, and negative 0.4 plus nothing still is negative 0.4. And then going back over to our time side, we did not have any correction for DST, so you can either put zeros or just draw a line through them like I'm doing, and then you'll bring your times down. So now you need to find the duration and range of your tide. So the duration is how long it takes. So you'll be subtracting 1544 from, or 952 from 1544, and you'll end up with 0552, and you'll do the same here. Except because there is a sign change, you are actually going to be adding 6.6 plus 0.4, 7.0. And since we want to find the range of tide with the height, so even though this goes below 0, because this goes below 0 rather, the height is greater, the range of height is greater. So you have it's like on a number line, you have your 0, and you have your positive numbers, and you have your negative numbers. We know the difference between these are 12. So that's basically what we're doing here. We want the difference of 6.6 and 0.4. So you can go ahead and write your duration of tide in the blank, 0552, and your range is 7.2. So now you get to the last 2 blanks. So your time to nearest high or low water, and your table 3 correction to height. So the question asking up here is, when will the height of tide at City Island, New York be 2.4 feet. So your correction to height is actually 2.4 feet in this particular problem. And now we need our time to nearest, which we also do not have yet. So our time to nearest, we'll take table 3, which is right here, and there's a lot going on. So we have our range of tide listed here. We have our duration of the rise or fall of tide listed here, and our time from the nearest high or low water listed here. So we have our range, we have our duration, we do not have our time to nearest yet, but we also have our correction, which is listed here. So we'll take our range of tide, which was 7 feet, and come into the table and slide the note card across, just to make sure that we're getting the right numbers. And then we'll go over until we hit 2.4, which is right here. Then we're going to slide this up until we reach our duration of 0.554, or 0.552, which is closest to 0.600, and make sure you stay in that same column, which I did not, but there it is. And our answer for our time to nearest is 0.221. So we'll take our time to nearest of 0.221 and plug it in. So now that we have all this information, what do we do with it? We still don't have our answer. So we'll take the 0.952 and we will add the 0.221 and come out with 12.13. So the reason why I added is because on this table, in the instructions, when the nearest tide is high water, subtract the correction. When the nearest tide is low water, add the correction. So our nearest tide was low water. So we were looking for a tide at 10 o'clock. And our nearest tide is 0.952 for that. So because we want as close to 10 o'clock as possible. So that's why I added the correction, because we used low water. So you have 12.13. It doesn't really match up with any of these answers, but that is the correct response because we don't interpolate between the tables. So you do have some of these inaccuracies. So your answer ends up being the closest one. Some of your problems will come out dead on, unlike this one. Some of your problems you'll be off just a couple minutes, and some you'll be off almost 10 minutes, like I am here. Feel free to leave any questions in the comments section, and good luck on your license prep.